In this video, I am doing problem number 8 from section 6.5. A Ferris wheel is 35 meters in diameter and boarded from a platform that is 2 meters above the ground. So let's label what we know regarding this. So the center of this, let's say that this is our midline. And so if the diameter is 35, that means that this is 17.5 and this is 17.5. And the bottom here is 2 meters above the ground. So that means if this is 2 and we add 17.5 to that, we're at 19.5. And then up at the top here, we would be at 37. So the top of our curve is going to go to 37. The midline is at 19.5 and the bottom is going to be at 2. Let's divide our graph into 4 equal sections and decide how we want to graph this. Now, the 6 o'clock position on the Ferris wheel is level with the loading platform. So the 6 o'clock position down here is level. So we're going to be starting down here at the low point. And then as this Ferris wheel rotates around, a quarter of the way around, it will be at the midline, which is going to be right here. So a quarter of the way around, it's going to be at the midline. And then as it rotates all the way to the top, it will have gone 1/2 rotation. It'll be at the top. So at a 1/2 a rotation, it's going to be at the top. And we're halfway through our cosine curve. 3/4 of the way through the rotation, it will be back to the midline. So it's going to come back down to the midline. And then it will reach the low point when it's made 1 complete rotation. So it will reach the low point again down here. So that is a very bad looking, but a cosine curve. And it's a cosine curve that has been flipped over the horizontal axis or the midline. All right, so let's take a look at what we know. We want to fit it into the formula y equals a, and so we're using the cosine function of bx plus k. And in this particular problem, there's going to be no horizontal shift, so I could left off the x minus h part. Well, in this case, the amplitude is 17.5. Try to move my little graph here. So this is going to end up being y is equal to negative 17.5 times the cosine. And we need to figure out what b is. Well, it also says that how many minutes? One full revolution is in 10 minutes. So 1 full revolution is in 10 minutes. That means the period is equal to 10. And we know that the period is equal to 2 pi divided by b, or b is 2 pi divided by p. So 2 pi divided by 10 is pi over 5. So b is pi over 5 times, I'll use a t here rather than an x for time. And then k is the midline, which is 19.5. So there is the basic function that we need to use to solve this problem. All right, now we want to know when, going back to the problem again, how many minutes of the ride are spent higher than 21 meters above the ground? Well, 21 meters, so if we have 19.5 meters is the midline, so 21 is going to be somewhere, let's say, up here. There's 21.5 meters, let's say. And so it's going to intersect the graph in two spots. So we're looking for this point and we're looking for this point right there. And so I'm going to call this x sub 1 and this would be x sub 2. And so at x sub 1, it's going to be going up above that level of 21 meters. And at x sub 2, it's going to be coming back down. So the answer to the question is going to be x sub 2 minus x sub 1 would be the total time that it is above 21. So how do we find x sub 1 and x sub 2? Well, first of all, we have to solve this equation when y is equal to 21. Our output value is 21. So I'm going to substitute 21 in for y. 21 equals negative 17.5. And I'm going to do a u substitution here, the cosine of u plus 19.5. Subtracting 9.5 to the other side, we're going to have 1.5 is equal to negative 17.5 times the cosine of u, or cosine of u is 1.5 divided by negative 17.5, which is going to be a negative 0.0857. So the cosine of u, is negative 0.0857. Now I know that the cosine is negative in this quadrant and in this quadrant. So this is our angle right here that we're finding. And we have to find another angle that's going to be all the way over here. Again, this is where cosine is negative and cosine is negative, and we have a negative cosine. So let's just call this x sub 1. Well, first of all, or u sub 1. So if cosine of u is equal to this, then we know that u is going to be equal to the arc cosine of negative 0.0857. And that's going to be my first value. This is going to be u sub 1. And then u sub 2 is going to be 2 pi minus u sub 1. So u sub 1, the arc cosine of that ends up being 1.656. 1.656. 2 pi minus u sub 1 is going to end up being 4.626. Now, we're not interested really in what u is. We want to find out what our x's are. So I'm just going to write u1 equals 1.656. u2 is equal to 4.626. And then going back to our substitution, we did a substitution where u is equal to pi over 5t. So we're going to substitute back in pi over 5t, t sub 1, I'll call that, is 1.656. And pi over 5t sub 2 is equal to 4.626. So that means t sub 1 is going to be 1.656 over pi over 5. And t sub 2 is 4.626 divided by pi over 5. And it turns out t sub 1 then is going to end up being equal to 2.636. And t sub 2 is going to be equal to 7.363. And up above here, I used x's. I should have used t's, x1 and x2. I guess be consistent, I should have called this t1 and t2. And so my answer is going to be t1 or t2 minus t1. So basically at t1, it's when it went above 21 meters, and at t2 it's going below 21 meters. So the answer to this problem is going to be T2 minus T1, or 7.363 minus 2.636, which ends up being approximately 4.72, rounded to 2 decimal places. All right, this was problem 8 from section 6.5. I hope it was helpful.